tell you something you already know. The world ain't all sunshine and rainbows. It's a very mean and nasty place, and I don't care how tough you are, it will beat you to your knees and keep you there permanently if you let it. You, me, or nobody is going to hit as hard as life. But it ain't about how hard you hit. It's about how hard you can get hit and keep moving forward. How much you can take and keep moving forward. That's how winning is done. Pain is temporary. It may last for a minute, or an hour, or a day, or even a year. But eventually, it will subside, and something else will take its place. If I quit, however, it will last forever.
All right, guys. So, figure I'd just start off this section notes with this little motivational video for you. You know, I know life is tough sometimes, and I fully know well that, math's not the easiest, but I appreciate you guys working hard, putting your best foot forward every single day, and making the most of it. Keep that good attitude, keep that good hard work ethic, and it will pay off, okay? No matter what you do, I promise it will, okay? So what you get in life is what you put into it. So here we go. We're going to take a look at our second part of our notes today. Kind of pick up from yesterday. I know you guys were working on the first half of this. I'm going to kind of keep going with it. Here's our application for the day. Your school is planning a 5-hour outing to the beach. The boardwalk rents bicycles for $8 per hour and skates for $6 per hour. The total budget per person is $34. How many hours should each student spend doing each activity? Now, what we're going to do here is come up with two variables, x and y. Okay? Now, I'm going to let x equal the number of hours for bicycles. Hours, bicycles. And we can let y equal the number of hours for skates. Okay? And I know total we spent 5 hours there. So I spent so many hours with bicycles, so many hours with skates. Now, as far as the price goes, $8 for a bicycle, so I'm going to put 8 times x, right, plus $6 per hour for skates, 6y, equals, I spent $34 total. All right. Now here is our system of equation. Now we just learned about substitution. So I'm going to take this top equation. I'm going to get either x or y by itself. Let's just go with y. I can subtract the x over. I get negative x plus 5. So now what I have here is y equals negative x plus 5. I can substitute this in. 8x plus 6 times negative x plus 5 equals 34. Okay? I can distribute the 6 in. 8x minus 6x plus 30, I'm distributing all the way in, equals 34. Okay, I'm going to do 2 steps in one here. Okay, 8x minus 6x gives me 2x. Subtract the 30 over, I get 4. Now divide both sides by 2, x equals 2. So that means 2 hours of bicycling. Okay, so 2 hours on a bicycle. Okay, well, I'm not totally done yet. My y is number of hours on skates. So if I know I spent 5 hours total, 2 of them on a bicycle, how many with skates? Well, 5 minus 2, 3 hours on skates. Okay? Very cool. Okay, excellent. If you ever get stuck on a problem like this too, I already had a nice conversation with a few of you guys yesterday. Try plugging in numbers, okay? Like see what you come up with, and eventually you might get the right answer as well. But this will definitely get you step by step to the correct answer. All right. Critical thinking. Write an equation which, when paired with negative 2x plus 3y equals 12 to form a system, has the given number of solutions. Exactly 1, no, infinitely many. So my first goal is I want to know what the slope is for this line, because I'm trying to relate it back to what we just took a look at with our graphs. So I'm going to get y by itself. So add the 2x over, divide by 3. Here we go. So this equation looks like that. Y equals 2/3 x plus 4. Now to have exactly one solution, all I need to do is make sure that it's not this exact same thing or parallel to it with a different y-intercept. So you can literally go, well, you can do infinite many things here. I could say like 5x minus 2. Okay? Because if I was to graph these two, it would be like when we said about the pirate thing, where X marks the spot, like that, okay? And then you end up having one solution. No solution means that the lines need to be parallel, but never intersect. Well, obviously that's the definition of parallel, but I mean like in terms of the y-intercept. So my equation could be y equals 2/3 x, okay? And then any kind of y-intercept here, minus 3. Good deal. Infinite many means exactly the same graph, so exactly the same thing. So I can say y equals 2/3 x plus 4, okay? If you would like to, just to kind of relate this for you guys real quick, here's my calculator, y equals, clear this out. Okay. My first graph, okay, the original one up top here, is 2/3 x plus 4. All right. Now let's look at the exactly one solution. If I type in 5x minus 2, graph it. Hopefully it shows up here because I don't know per se if it's exactly. There we go. Awesome. So it crosses right there, one solution. There we go. I verified it via graph. All's well. Back to my y equals. I'm going to clear out this one. Let's type in our 2/3 x minus 3. Graph it. Once you know it, we have our two parallel lines. They're never intersecting, hence no solution. Okay. Lastly, my infinite many solutions. Okay, I'm going to go back to y equals, clear out your second one. And y equals 2/3 x plus 4. Well, they look exactly the same, and wouldn't you know it, we're going to get exactly the same thing going on here. Okay, same graph overlapping. Perfect. So we just verified everything for you. Okay, awesome. Okay, your last page for this particular section. Here we go. Now, this is by far and away my favorite out of the three. It's called elimination method. One final method to solve systems of linear equations is called elimination. Sometimes it is called linear combinations or addition method. The steps to solve a linear system by elimination are listed here. So we got 4 steps. Arrange the equations with like terms in columns. So we want x's over x's, y's over y's, numbers over numbers, and equals shall all be lined up. Step 2, multiply, if necessary, the equations by numbers to obtain coefficients that are opposites for one of the variables. We want things to cancel out here. We want an x to go away. We want a y to go away. All right. 3, add the equations. 4, substitute the value obtained in step 3 into either of the original equations and solve for the other variable. So let's go through number 1 together. All right. Then we'll let you guys try out a few on your own here. So number 1. 2x minus y equals -8, 2x plus y equals 4. Now, the way this is set up is great. I have everything lined up, everything looks good, okay, going across. What I'm after here is, do I have something that has opposite signs and of the same value? So 2 and 2, they're both the same, but they're not opposite values. So they're not going to cancel out if I add them. However, look at your y's. Negative y, so -1 and a positive 1. If I add them, they will cancel out. So let's go ahead and give this a shot. I'm going to add these two together. What is 2x plus 2x? Well, 4x, all right? It would be like saying 2 apples plus 2 apples gives me 4 apples, not 4 apples squared. Don't confuse that with multiplying. Negative y plus y cancels out, gives me 0. Negative 8 plus 4 gives me -4. Okay, cool. Now, I have one last step here. Divide both sides by 4. X equals -1. I like it. We're not quite done yet. Here's where you have a little bit of freedom. Take your -1, plug it back into either one of these equations. I'm going to go ahead with the first one just because, why not? 2x minus y equals -8. Replace the x with -1. Okay, 2 times -1 gives me -2 minus y equals -8. Add the 2 over. Negative y equals -6. Okay, please don't get confused here. -8 plus 2 gives you -6. If you have to, back yourself up with the calculator. Divide both sides by -1, we get y equals 6. Now, I know it looks like we're done. We got our x and our y. Always put your answer in terms of a coordinate. So -1, 6, and yes, the parentheses are important. okay? So I'd like you guys to try out the next few. I'm going to give you the first step to number 2, though, okay? I have y over y. Cool. I have negative 2x over negative x. All right. This looks promising, but they're not the opposite signs. So what you can do here is multiply everything through by negative 1. Let's see what happens. Y minus 2x equals negative 5. If I multiply through by negative 1, I get negative y plus x equals 3. Now you can go ahead and do the steps we did over here. Combine like terms, okay? Get your x's by itself, solve it, plug it back in, and go from there, okay? Cool. And over here, one little extra hint for you guys. You're going to have to multiply through by a number, not just negative 1, but by a number to get something to match up, okay? Wonderful. So pause the video now if you have to. Try out number 2 and number 3. Again, I'm going to be around the room to help you if you need to, so by all means, feel free to ask questions. All right. Lastly, okay, our application problem, the kind of extension here. We can take a look at this, and we're going to start off by reading the problem. Okay, so postcard stamps are 33 cents each, whereas regular stamps are 46 cents each. If you have 36 stamps worth $15.52, how many of each type do you have? So let's get you guys started on this one. I'm going to call X being postcard stamps. Number, postcard stamps. All right. I'm going to call Y number of regular stamps. So let's set this equation up. How many total stamps do you have? Well, it's kind of hidden in this problem, but if you have 36 stamps worth. So I know my postcard stamps plus my regular stamps will add up to 36. Like I know I have 36 total of them. Meanwhile, the price, postcard stamps, which is my X, so 0.33 X plus 46 cents stamp for each regular, 0.44 Y equals 15.52. Okay? That's all we got right there. We have everything set up nicely. So for this problem, you can try elimination. You can multiply the top by a constant, okay? But you're trying to figure out how many of each stamps will make that work out, okay? I'll leave you here at this, and at the end of the period, we will review it, okay? Again, keep up the good work, all right? Keep trying these things out. Always ask questions if you need to. And as always, good luck. We are all counting on you.